So we're back again here. We've just taken a quick little coffee break and we finished writing our givens. Let me go ahead and get my pen attachment here. We've written our givens, and up here we have our two given statements, and then we move in and we say HI is equal to IJ. Well, HI, that's right here, is equal to IJ. That is by the substitution property. We can take IJ, HI is equal to 9. We can go ahead and stick IJ in for 9 because they're both equal to 9. So that's the substitution property. And then we move on to the next step here and we say segment HI is congruent to segment IJ by the definition of congruent segments. They have the same length. That one's pretty straightforward. Moving on to the next property, we have segment IJ is congruent to JH. Well, let's look at IJ. That's over here. IJ is congruent to JH. Well, we already have that as a given. We've already marked that with our two little tick lines there. So, and that was a given right up here, so we can just say given. Moving to the next step. Ooh, we can use steps 3, 4, and 5 and say A is equal to B. 4, 5, and 6. So let's do that instead. We can say A is equal to B. That's the HI is equal to IJ, and then B is equal to C, and therefore A is equal to C, which goes ahead and proves our property. HI is equal, segment HI is congruent to segment JH. Let's go ahead and look at another problem. This one's to do with angles, and we're given the measure of angle, or angle 3 and angle 2 are complementary. You remember that angle 2 and angle 3 are complementary. That means angle 2 and angle 3 added together must sum up to 90 degrees. We had a definition, but that was a complementary definition. Sum to 90 degrees. They also gave us measure of angle 1 and measure of angle 2. These two angles sum to 90 degrees, equal 90 degrees. So starting off with our given here, we have angle 3 and angle 2 are complementary. That's our given, first given. Second given, measure of angle 1 and measure of angle 2 equal 90 degrees. That's also given. And we're trying to prove that angle 3 is congruent to angle 1. So we can say measure of angle 3 plus the measure of angle 2, which we're getting from up here, equal 90 degrees. And that is the definition of complementary angles, which is what it sounds like. Going on to step 4, so we've got A is equal to B, we've got B is equal to C, and now we can say A is equal to C. And once again, we're having the transitive property, so we can say this is equal to this because they're both equal to 90 degrees. So the transitive property. And then we can go ahead and subtract the measure of angle 2 from both sides, which leaves us with, we're subtracting, gets rid of angle 2 from both of them. And that's the subtraction property of equality. And that leaves us with angle 1 is congruent to angle 3 because their measures are the same. Definition of congruent angles. That was a fairly straightforward proof. Going to the last problem. AL equals SK. So this, I'm marking up my diagram. Those two things, that is given. LS equals LS. Well, this has to equal itself, doesn't it? So what can we say about that? What property is that? That'd be the reflexive property. And we can put PROP out there for property. And now we're adding LS to both of these things up here, aren't we? So that is the addition property of equality. And yes, you can go ahead and say it out loud if you want. What's the next step? AL plus AL, LS equals AS. So AL plus LS equals AS. Segment addition postulate. Segment addition postulate. And they're doing the same thing again here. Let's see if we can do this one in a different color.